Hi, in this video we're going to talk about global and local scopes. So, scopes and namespaces. Well, let's take a look at what happens when we assign a value to a variable, or we assign an object, technically, to a variable, right? Like a equals 10. Then, as we know, we've created this variable, this label called 10, and it now references an object in memory at some memory address that contains that integer 10. So we always used to say the variable points to that object. Another way that we can say is that the variable, that name, right, because the variable is just a label, right, it's a name, is bound to that object. That's just another way of saying it references that object. Now that object can be accessed using that name, using that label in various parts of our code. So for example, if we say a equals 10 and then we say print a, then we are actually asking Python to give us back whatever a was bound to. And maybe, a few lines down the road, we say a equals a plus 1. We're doing the same thing. We're taking the current value of a, so we're asking Python to give us back the value that that label a is bound to. We add 1 to it, and then we store that back. We bind that new value, 2 in this case, or depending what a started off as. If it started off as 10, we'd have 11. Now we bind a to a new object, 11. Right? So we've seen that in the past. But of course, we can't just reference a anywhere in our code. There might be places where that label doesn't exist, or maybe that label exists, but it means something else. And we've seen that before. If you have code, let's say in your module, you have variable a, and then you define a function that has a parameter called a, then when you pass that value inside, let's say you pass in a value to that function as an argument, well, the a that is inside the function isn't necessarily the same value as the a that's in the global module. So you can't just reference a anywhere, and even if you could, it doesn't mean that it's necessarily the same object that you're talking about. So there is this concept that the name and the object that it's bound to only exist in certain sections of our code, in specific parts of our code. Now the portion of the code where that specific name binding that we're looking at, that we're interested in exists, is called the lexical scope, or simply the scope of the variable. So we'll take a look at that in more detail. But one of the things that's associated with that scope is that these bindings are stored somewhere. So yes, they exist in that scope, right? So a equals 10 exists in some scope, right? Because that binding exists. But where is it stored? Well, it's stored in something called a namespace. And we can think of a namespace simply as a table that contains the label and the reference that it's pointing to, that it's bound to. So namespaces and scopes go hand in hand because every scope has a namespace. So let's talk about the global scope first. Now the global scope is essentially the module scope. It spans a single file only. So when you create a module in Python, you have a global scope in that module. There is really no such thing as a truly global scope that goes across all of the modules in our entire application. Not in Python. Now you do have something that's kind of global, truly global across all the modules, but that's the built-in scope. That's the scope where objects like true or false or even none, right? But also dict and also print. Print is a function, but it's just an object. So it has to live somewhere, right? It's living in a namespace somewhere. When you ask for Python to use print, to call the print function, it has to go and look up and say, well, where's the object for print? So you can think of that as another scope, and that's kind of available everywhere. That's called the built-in scope. So the built-in and global variables can be used anywhere inside our module. Right? So anything that you define in the module, let's say a equals 10 at the module level, you can now access that a equals 10 after that point, and it will reference that particular label a everywhere in your code, even inside functions. And we'll see how to do that. So global scopes are nested inside the built-in scope. Let's see what I mean by that. So we think of these scopes basically where things live, right? Where we have namespaces and things live in those namespaces. So that built-in scope has a namespace. And a namespace is just a label and basically a pointer to an object, whatever it's bound to. So it's the bindings of the label to the objects. So in the built-in scope, you might have bindings for true and false and print and so on. But now when we load up our module, let's say we have a module called module 1, well, that module has its own scope and it has its own namespace. But we think of those as being nested one inside the other. Same thing if we have another module. We have module 2. It has its own scope. Now it's distinct from module 1. It doesn't intersect. There is no overlap between those two module scopes. But it has its own namespace. However, it does live inside the built-in scope. So why do we think of it as being nested? Well, because when you ask for Python to give you the object that's bound to a label, it needs to go look it up in a namespace, in one of those tables. So where does it look? Well, if your code is sitting inside module 1, it's going to look in the namespace for that module 1 scope. It's going to look in this namespace right here. If it doesn't find that binding, if it doesn't find that label that you're asking for, let's say you're in module 1 and you ask for true, you want to say, you know, A equals true, and it needs to go look for this object called true. Well, if it doesn't find true inside your module 1's namespace, it's going to then go up into the enclosing namespace, which in this case is the built-in scope namespace, and it's going to look for it in there. And if it finds it, great, right? So that's how Python works. It always looks at the current scope, and if it can't find the binding, it starts looking outwards at enclosing scopes. So let's do an example. Let's say we have module1.py, and we say print true, right? That's the only line in that module. So what's happening here? Well, Python doesn't find true, and it doesn't find print in the module or the global scope, right? It doesn't find print and true in module 1. We haven't defined print and true in module 1. We're just saying print true. So we're using these things without having defined them already. So they're not in the local scope, or at least they're not in the module scope. So now Python says, okay, well, let me go look, one step up. Let's look in the built-in scope. And of course it finds both the print function and the true object, or the true label, so the print label and the true label in the enclosing scope, in the built-in scope. And so it's going to use those. And that's why it prints out true. Let's take a look at another module. Let's say module number 2. And this is the only line of code that we have in the module. We have print A. Well, you probably should know by now that print A is going to cause a runtime error. Why? Well, A is not defined. Well, what does that mean, not defined, right? Well, here's what happens. Python doesn't find A or print in the current, which is the module or the global scope. So what does it do? Well, it's going to go and look for them in the built-in scope, right? It looks up if it can't find it in the current scope. So it finds print, that's great, but it doesn't find A. And there is nothing above the built-in scope. So at that point, Python says, sorry, but I can't find A anywhere. You can't use it. It hasn't been defined. And so you get this runtime name error. Let's take a look at module number 3. And let's say that we have this. Now, here we are assigning something to this variable, this label called print. But remember that print is also a built-in. So print is a label that exists in the built-in scope. However, here we're assigning a value to print, which means that print now lives in the local scope of module 3, in the global scope, right? In our module scope. And here we've just defined it to be a function. So we're saying, well, print is still a function. And it's going to take in a single parameter, and it's going to return this string, hello, and then whatever the parameter was. So now if we say s equals print world, it's not going to call Python's built-in print function, because Python is going to say, oh, you want print. Well, let me look in the current scope, which is the module scope. I found it. All right, I'm going to use that. So it uses the print function. And so what happens here is that we've essentially overridden what Python's print does, right? Where we've changed the meaning of print. So that's also called masking, right? We've masked the original print. So usually it's not a good idea to do that, right? Because you want to keep your print function. So if you redefine it to mean something else, how do you tell Python, well, I don't want my local one, I want the one that's above? You can't. So you would have to delete it. And you can do that. I'll show you in the code how you can do that. So we've talked about the built-in scope, and then we've talked about the global or module scope that lives inside the built-in scope, if we think of them as nested scopes. But when we create functions, functions also have their own scope. So when we create variable names inside those functions, so we take labels and we assign an object to them, we're essentially binding a label to an object. Well, that lives in the scope of that function, right? When we assign a value. So for example, when we say a equals 10, well, variables defined inside a function, though, are not created until the function is called. Because remember, how does it work when you have a def, let's say, in a module, and you load up the module? Python goes through and it basically compiles everything. So it finds your function. It says, okay, you've created a function, fine, I'm going to take that function name and I'm going to put that into the module's scope, into the module namespace. But the contents of the function, what's inside the function, doesn't run. So there's nothing that's actually running. There's no code running. So there is no scope that's being created when the function is created. The scope will get created when the function is called, but not before that. So every time the function is called, a new scope is created for when that function runs. And that kind of makes sense because you can call a function, let's say, with different values for its parameters. And of course, that means that every time the function is called, it's got different bindings for its, for its variables. The parameters are variables. The arguments, are labels that are bound to some value that we pass in when we pass the arguments. And every time we call the function, those values could be different. So the bindings could be different, which means we really have a different scope every time. So variables are defined inside the function that are assigned to that scope. So in other words, if you make an assignment like a equals 10 inside a function, then that variable a, that label a, is put inside the scope of that function, and it's called a local scope. It's called the scope of the function, the local scope. So the actual object that the variable references, of course, could be different every time the function is called, right? And that's why recursion works, because we're able to call the function from inside the function, but every time we pass a different value, and every time we call the function, it gets its own scope. And we'll see that in the code. We'll look at some examples. Let's look at one here. Let's say we have def myfunc a comma b, and c equals a times b, and then we return c. So what are the labels that are local to this function here? Well, obviously, a and b, the parameter names, right? These are going to be local to that function. They don't exist outside of the function, they exist inside the function. C is another one. We're assigning something to C, so we've just created this new label C, and we're binding it to some value, the product of A and B. So when Python looks at this, at compile time, and this is really important now to differentiate between compile time and runtime, because at compile time, when Python encounters this piece of code, it makes some determinations. It looks at everything in here, and it says, okay, so for my func, A, B, and C are going to be local variables. It doesn't create the scope or the namespace because we haven't called the function, but it predetermines at compilation time that A, B, and C, when they will be created and put into a namespace, will be into a local namespace, not the module namespace and certainly not the built-in namespace. So these names will be considered local once they get created. So now if we call myfunc z, 2, what happens? Well, now Python creates a scope. And the scope is of this function as it's running. So when the function runs, we have these three variables a, b, and c that are in the local namespace. And they have values z2 and zz. Now once the function exits, the scope, by the way, goes away because the function is finished, so that scope is no longer needed and it's cleaned up. And we'll come back to that in a second. Let's say we call myfunc again with two different variables, 10 and 5 this time. What happens? Well, at that point, we're calling the function, Python creates a new scope, and it creates those variables a, b, and c in the local namespace, and it binds them to these values, 10, 5, and 50. So we have different scopes every time a function is called. The scope does not get created when the function is defined. The only thing that happens then is that Python makes a determination of all the labels that are going to be in that function that will be used or referenced or assigned, and it figures out, are they local or are they something else? Because they could be global in the module or they could be built-ins, right? So same names, right? The same variable names, but they're in different scopes, and therefore they're not bound to the same objects. They have different values. So what about nested scopes? We've already seen global scopes or module scopes being nested inside the built-in scope. Well, the same thing happens with functions as well. So if we start with the built-in scope, then we have the module scope that's nested inside. And we think of this nesting because that is how Python looks for variable names and for labels, right? It starts in the current scope. So if you've got code in your module, it's going to look for the labels binding in the module namespace. If it doesn't find it, it's going to go and look in the built-in namespace. And if it doesn't find it, then we have an error. But if we have a local scope, like when we have a function, and we reference something inside that local scope, then Python is going to look in the local scope first. If it doesn't find it, then it will go look in the module scope. And then it will go look in the built-in scope. So we always think of scopes as being nested. Now, when we call the function the second time, then we have a different local scope, right? Or maybe it's a different function. That's obviously going to have a different local scope as well. So we think of the scopes as being nested. So the namespace lookups, so when requesting the object bound to a variable name, I just want to repeat that because it's really important. What happens? Let's say we say print A. Well, let's not worry about print. We know print's going to go into the built-in scope. So it will try and find the object that's bound to the variable somewhere, right? We're referencing this label called A. It now needs to look for it. So it's going to look in the current local scope first. So if we're running a function, then it's going to look in that current local scope for A. If it can't find it, it's going to go and work its way up the enclosing scopes. So it will look in the module scope, and then it will look in the built-in scope. Now we'll see in not the next video, but the one after that, we can actually create functions inside functions. So you can have, of course, a lot more nesting than just local to module to built-in. You can have local within local, right? Within module, within built-in. We'll take a look at that. So let's take a look at another example. So the built-in scope contains true, right? We know that true lives there. So let's say that we have now a module that we've created. Let's say module 1. So as soon as we load module 1, a global scope is created for the module, or a module scope if you want to call it that. Now our first line of code says A equals 10. What happens? Well, Python says, okay, you're making an assignment to a label A. So I need to create this label and bind it to 10. Where am I going to create it? I'm in the module. I'm going to create it in the module scope. So it puts A and binds it to 10 in the global scope namespace. Now we define a function. Let's say def myfunc takes a single parameter called b, and then we have these 3 lines of code: print true, print A, print B. So what happens as soon as Python encounters this line of code? It's compiling the function. It's not running it, right? But it is going to make the determination that myfunc, it has to create it. So that's being created. That's a label that's going to be in the global scope. But that's it. That's as far as it goes in terms of creating variables and bindings. However, it does look at this and it says, okay, B is going to be local and A, however, is going to be global. Because, well, it actually doesn't say A is going to be global. It's going to look at A and B here because it's a parameter to say, okay, this is local. A here it's not going to do anything. It's going to say, well, don't know yet. We'll find out at runtime what's happening. But it's a non-local variable, and we'll come back to that. So now when we call myfunc of 300, what happens? Well, now we're calling the function. So the local scope is created. We've passed 300 as an argument to myfunc. So now Python says, okay, now I'm assigning 300 to B. It's an assignment, right? So it creates B and binds it to the object 300 in the local namespace. And now when we print true, it's going to go ahead and find true in the built-in scope. When we print A, it doesn't find A in the local scope, you'll notice. So it goes up 1 and finds it in the global scope. It says, okay, so it will print 10 out. And then when we say print B, it's going to look for B starting in the local scope, finds it, it's going to print 300. If we call myfunc of A, we're creating a different local scope. And here we're passing A and we're assigning it to the label B. So now B is going to be bound to the string object A in the local scope. And so we're going to print, again, true, 10, and A. Now, if you remember reference counting that we did way back in the beginning of the course, right? We talked about objects, and then every time we reference them, that means we have, let's say, a label that points to it, that increases the reference by 1. Well, what happens with the local scope is that once the function finishes running, all these bindings go away. They're cleaned up. The local scope is destroyed, right? The namespace is destroyed, which means that all these references are gone. So whenever you run myfunc 300, well, this 300 object, if it doesn't already exist, gets created, and its reference is incremented by 1. So now it has a reference count of 1. But maybe it already existed, and then it just increases the reference count and points B to it. But as soon as myfunc finishes running, the scope is destroyed, and the reference count for that object is decreased by 1. And then potentially we have garbage collection and memory management that happens. So we say that the reference count is decremented, right? Because we're removing a reference, and we say that the variable goes out of scope. So now this label here that was B is no longer available once the function finishes running. So inside the function, B is available. Outside of the function, once the function is finished running, B has gone out of scope. It doesn't exist anymore. Or at least not that particular B with its particular binding. So how about accessing the global scope from the local scope? Now we've seen that when we try and access something, let's say we want to reference the value true, right? The label true. Then we know that Python is going to look at the local scope, doesn't find it, might go to the next scope up, maybe it's the module scope, doesn't find it, looks at the next scope up, which is the built-in scope, finds it, uses it, right? So when retrieving the value of a global variable from inside a function, Python automatically searches the local scope first, and if it doesn't find it, then it works its way up the chain of scopes and their namespaces. So it starts at the local, goes to global, and then we'll see that we can have multiple locals in between. But for now, let's assume it's just a function inside a module. So it goes from local to global to built-in, right? That's the way it searches for that particular label. But what about modifying the global variable from inside the function? So let's look at this code. Let's say we have a equals 0, and then we define myfunc, and inside of myfunc we set a equal to 100, and then we print a out. What's critical here to see is that this is an assignment operation. Whenever there's an assignment, Python says, okay, I'm creating something, right? I'm creating a new label. I'm going to bind it to something. So at compile time, not when the function is called, but when the function is actually compiled, when Python actually sees the code, not runs it, but actually sees this function, now it creates the function. It makes a determination that a is going to be a local variable to the function. Doesn't get created yet, but it's going to be local. That gets determined at compile time. So the local variable a here is masking the global variable a, right? Because When we say print A here, which A is this going to refer to? Well, Python's going to look for that label A in the local scope first. That's where it's living, that's where it's going to start. If it doesn't find it, then it will go and look in the global scope. However, in this case, it finds it. Because when we said A equal to 100 when the function's running, because Python determined that A is going to be a local variable, it says, okay, A is equal to 100 goes in the local scope, in that namespace. When we say print A, Python finds A in the local namespace. It uses that value for A, that binding, not the one that's in the global namespace. So we say that A masks the global variable. So let's see what's happening. So we've got our built-in, we run our module, so we get our global namespace. We create A equals 0. Okay, so now we have A is 0, right, in the namespace. Then we create this function. So now we have myfunc, which is bound to this function, whatever the function is in memory, it's just an object. And this label is myfunc, is bound to that function. But that's it. Now when we run myfunc, then we get this local namespace that gets created at that point. The first line of code says A equals 100. So Python is now going to set A, it's going to bind A to the object 100, but which namespace is it going to put it in? It's going to put it into the local namespace because it made that determination that if you're assigning a value inside the function, it goes into the local namespace. And so when we print myfunc, it's going to print 100. When we run myfunc, it's going to print 100 because A is 100. It's not going to print 0. And if we print A after myfunc has finished running, what are we going to get? Well, we're going to get 0. We didn't modify the global A, right? When we set A equal to 100, it didn't change the value of A in the module because it wasn't the same A, because they were in different scopes. So what if we do want to do that though? What if we want to set, change the value of a variable that's in the global scope from inside a local scope? Well, we can do that by using the global keyword. It's kind of almost like a declaration. We're going to tell Python, and we're going to tell it saying, well, look, I'm going to use this variable A here, and I'm going to assign it a value, but this variable A is not local. Please make sure that it lives in the global namespace. If it doesn't exist, create it there. If it exists already, use that. So let's see how we do that. So let's start again with the same example, A equals 0. So now we've got our built-in and our global with A is 0 is in there. Now we have this function, right? So we run this function. We don't run the function. Python looks at the function, compiles it, creates the label myfunc in the global namespace, in the module namespace. And at that point, it sees that we have A equals 100. So normally it would say, well, A is going to be local. But you'll notice this line of code right here, where we say global A. This is telling Python, it's like, wait a minute. Yes, I'm assigning a value to A, but this A is actually in the global namespace. So you're basically forcing Python to recognize that this A here means this A out here in the module, means the one that's in the global namespace, right? So now this A is going to be, when this function runs, this A in here is going to be referencing this namespace, this label A in this global namespace. So if we call myfunc, then a local namespace, a local scope is created. And when we print A, what are we going to do? Now we've finished running, so the scope disappears. But when we print A, we're going to get 100 because, yeah, inside of myfunc, when we called it, we modified A. We set A equal to 100. But which label A was it? It was the one in the global namespace. All right, global and local scoping. So I really want to emphasize this a few times because that's really important. So when Python encounters a function at compile time, not at runtime, but when it first sees that def, right, or that lambda, it says, oh, I've got to create a function. So now it's going to have to do that. So what happens? It will scan basically for any labels or variables, however you want to call those things, that have values assigned to them, right? Anywhere in the function. It doesn't matter where it occurs in the function. It's going to find all these assignments and whatever's on the left-hand side of that assignment, those labels, it's going to say, hey, if you haven't told me these are global, they're going to be local. Now, remember, it doesn't create the variables yet, it doesn't create the namespace, it doesn't create the scope because we haven't called the function. But it basically puts aside saying, these are going to be local, these are going to be global. Right? So variables that are referenced but not assigned a value anywhere in the function will not be local. So if you say print true, it's not going to say, oh, true has to be a local variable. It's going to say, no, it's not local. You're not assigning a value to it, right? And you didn't declare it as global, so it's not local. I don't know what it is, but it's not local. And at runtime, Python will then look through the enclosing scopes to figure out what it is and if it's available somewhere. But it's only in cases when you're referencing a variable but not assigning a value to it. As soon as you assign, it becomes local, unless you use the global keyword. So let's look at an example. Let's say we have a equals 10, and we have this function here, def func1 print a. What's happening here is that a is referenced only in this entire function. So at compile time, Python determines that a is non-local. So when we run this, we're actually going to print the value of the global variable. When we call func1, it's going to print out 10. Now let's have another function. Let's say def func2. And we set a equal to 100. What's happening here is that it's an assignment. So at compile time, Python says a is local. And so when we run func2, when we call func2, it will create a, set it and bind it to 100, set its reference to that object in the local namespace. So it will basically mask this a that's in the global namespace. Let's say we've got this function here, def func3, and global a and a equal to 100. Now here, Python sees the assignment. So normally it would say local. But before we've actually assigned, we said no, global, a is global. So now Python recognizes that, okay, so you mean the a that's in the global namespace. So it's going to say a will be in the global namespace. Now a may not exist. You could say global b equals 100. After the function is exited, you'll now have a variable called b in the global namespace. Okay, Python will do that. It's fine to assign a value. Now you can't reference one before it's been assigned something, right? You can't reference b if you haven't assigned a value to b, but you can certainly assign a value to b. It will just create it. So at compile time, it determines that a is global. What about this? Def func4, this is kind of the interesting one, and this is where it kind of all comes together. What's going to happen here? Well, remember, at compile time, Python looks at func4, and what does it see? An assignment. Okay. Have we defined that a is global anywhere in this function? Nope. So what happens? A is local. So now a is going to be local. So what happens when we call func4? I mean, here we're referencing a. Is it going to go and look at the a in the module? It should, right? Because we said, well, if we can't find it in the local namespace, then you need to look up in the enclosing namespace, which is the global namespace. So a doesn't exist, so we need to go and look in the module. But a does exist. At that point in time when the function runs, a exists. It's in the namespace. It hasn't been assigned a value though, right? Because we assigned the value in the second line of code. So a exists, and we're trying to reference it before we've assigned a value to it. Because now, when we say print a, Python knows a is local, because it's already made the determination at compile time that a was local. And so when we call func4, we get a runtime error, right? So it's not like it's going to use the global variable here and then make a local variable here, right? If you have an assignment to a anywhere in the function, it will then, and you haven't set global a, it will make it local. And so you can't start referencing it before you've assigned a value to it, right? If you took this outside of the function and you just had print a and a equals 100 in the module, you would expect a runtime error, because it's like, well, I haven't created a yet, right? I haven't assigned a value to it yet. So let's switch to some code and let's see all these nitty-gritty details in action. Thanks for watching. I'll see you in a bit.